technical challenges I never found to be the hard ones. It's always the human ones that I thought were the hard ones, for me anyways. You need to be able to communicate, you need to be able to talk in human terms, but if you don't have deep technical understanding, you don't have any credibility.
Hello there, everyone. I'm Tim Berglund, and welcome to Confluent Developer, the podcast where we explore the fascinating journeys of software developers tackling really hard problems. In this episode, I'm interviewing Will LaForest. He's a field CTO for Confluent. Will and I have worked together for, well, a long time, and today I got to talk to him about a high school science fair project he did, of all things. And it wasn't even a science project. He just wrote some code he thought was cool. I really get that. Then he learned some really important lessons about how to bridge the gap between the technologist's fascination with things and how they work to the needs people have in understanding those things in terms that matter to them. Those are lessons we all need to learn. Let's get into it. Hey, Will, how's it going?
Good, actually, aside from being really, really cold.
So, Will, you're a field CTO, right?
That's what they say.
That's what they say. What would they say that what would you say that a field CTO does? For anybody who isn't familiar with sales organizations, what do you do?
Yeah, well, I mean, it's a fancy title for saying that I spend a lot of time talking to customers, helping them sort of solve their problems with, of course, in this case, Confluent, gathering signal from customers, like what are the problems they're running into? What could we be doing better at Confluent? So obviously that's bringing it back to product is part of that. And then I think just expressing what this technology space can do in terms of that matter to them, like in their business. Right? I think that's actually, interestingly, one of the sometimes the hardest things, because when you're talking to executives, as much as you and I both love technology, right? Mm-hmm. They don't necessarily know or even care what Kafka is. Right?
Maybe tech isn't their background. Maybe it's been a little bit, and they're not au courant on everything that's going on these days.
Yeah. So a little bit of this, a little bit of that.
Right. But that's the difference. To be a field CTO, you have to basically have had a background as an engineer of some kind or a technical person in whatever space you're in. But you need to be able to articulate those things in terms of somebody higher up the food chain.
Yeah, exactly. That's sort of the axis of skills required. I think you need to be able to communicate. You need to be able to talk in human terms. But if you don't have deep technical understanding, you don't have any credibility, right?
Nope. So, right. Because there's other folks in the room who will call you out.
For sure.
Okay, that's what you do now. Let's go to the other end of your employment journey. What was your first job?
Well, kind of depends on how you define job.
Okay. That's spicy. Go on.
No illicit, non-medicinal drug vending.
Okay. All lawful activity here.
But when I was 10 years old, I did stuff flyers in people's doors for pizza delivery. So I did do that, and I did get paid money,
cash money.
I guess, but okay. So aside from that, I think the first, job where I actually had to figure out, I was like, oh my gosh, who's the IRS?
Well, somebody was reporting to the IRS. Yeah, there's a W-2.
Yeah, why are they taking money? I was kind of very blessed, if you will. I had a paying internship at DARPA for 2 summers in a row, and that was fun time. So that was really good.
College?
I guess you could say that was my first paying job.
Yeah. That was college?
High school.
High school. Okay.
That would have been 1991, summer of 92 and summer of 93.
Yeah. Okay.
Yeah.
That's kind of cool. What did you do there?
Well, this was formative for me. This is when I learned to program assembler. So that was nice. That was fun.
Nice. What processor, if I may?
Well, in this case, it was an embedded RISC-based processor.
Okay. Okay. I was also writing firmware in the early to mid 90s. That's a good place to
Okay,
start.
wow. I had no idea.
Yeah.
So that was fun. Up to that point, I'd been doing I'd done a lot of languages, Pascal and C. And,
As one did at the time.
yeah, as one did at the time. So Pascal was always in the computer science. How do you learn program? You're going to learn Pascal.
And that just doesn't happen anymore.
So that was fun. I fell in love with Next computers there. Next Step, if you remember. Okay. So I did a little bit of Objective-C. Mm-hmm. So yeah, I did a little bit of this, embedded systems, and then I did some Objective-C programming to do some sort of administrative tasks. Nothing mission critical, of course, but it was good. It was fun.
Nice, cool.
Yeah.
So between Field CTO now and either paper delivery, pizza delivery flyer boy, or intern writing Objective-C, what would you say maybe one of the top most interesting problems you've solved?
So yeah, so interesting problems. Because I was thinking, do I go the direction where I talk about the hardest problems or the interesting problems? Because they're not.
Your call. Your call.
Yeah.
This is your interview.
I'm gonna go hardest problems simply because I suspect you talk to a lot of really smart people that talk about really technically sophisticated and interesting problems they solved. And I did some of those for sure. I did some fun stuff when I was at MarkLogic and stuff. But I think you probably get enough of that in your interview. So I'm going to go to the opposite spectrum because I think when I was sort of contemplating in preparation for this conversation, so this is a cheat for everyone watching out there. Yes,
there you go.
You do think ahead of these things.
Yes, I did let Will know what I was going to ask him.
Yeah, exactly. I thought about this and I was like, the harder problem that I think can tie to my current job really came down to, I think, okay, so I'll set the scene. So and I'm going to roll back the clock because I've seen this movie a few times. They're kind of related. I'm going to roll back the clock to 1991. So I did, I was in high school. Mm-hmm. I did a science fair and my project was, at the time, I was really fascinated by, they called it AI back then. But essentially it was, how do I play AI? And I was running, 486 on DOS. And so, so my first project was I made in what I called an AI baseball pitcher. Actually, a friend and I did. Okay, so that was pretty successful. That was great. So now fast forward to the next year. So
that was just software. There was no robotics or anything like that.
No robotics, yeah. And so, exactly. So we simulated basically, I did profiles of batters, and the trick was, could we use, essentially this was a single layer neural network sort of AI. Mm-hmm. Could we use that to try and improve our chances against these batters?
Okay.
So it was kind of fun.
Neural network in 1991 was a relatively new idea. Certainly in the hacker or undergraduate space, that would be hip and cool and new.
Well, I mean, and the only reason why I even knew it, because back then, at least when I was at DARPA, obviously I got introduced to the internet, but prior to that, there was bulletin board systems and 300 baud modems and stuff. You couldn't just find this stuff on the internet. I just happened into a book at a university bookstore that was on this. And that's why I started reading. I was like, you know what, I'm going to try this. So anyways, that was cool. But the next year I decided to take it to the next level. And so this is going to sound ridiculous, but so my friend and I decided, okay, can we apply this to general knowledge? i.e., if someone asks a question, could we recall something? And so that sounds like the interesting challenge I want to talk about, but that wasn't. And in fact, we gave up on neural networks. It was just way too hard. Instead, we just did essentially some heuristic-based natural language processing. It was really terrible. If you use the wrong grammar, it wouldn't work at all.
Eliza level. That stuff did not work then at all.
No, it was terrible. I mean, it would probably have been bad for anyone, but we were high schoolers programming in C. So
yeah.
And we did a knowledge graph. So that was kind of fun. But here's the challenge. I'm getting to the punchline. The punchline was the night before the science fair. We're putting the finishing touches on it. I don't even remember what happens now, but the bottom line is we lost everything. And like we had 3.5-inch floppies, and we like I knew code was on one of these things, and we just couldn't find it. And so we were in this point, like, what do we do now? Because clearly what we did the previous science fair was to sort of show the learning in process, to show how like the pitchers were getting better against batters. And we could actually demonstrate this for the judges. Back then, your science judges were not computer people. Like they're
not gonna. And if I may, pet peeve, raising my own kids, they were homeschooled, but there'd be like an enrichment program. There'd always been a science fair because I'm their dad. Obviously that's going to happen.
Yeah.
And science fairs are usually, there's this big push to use the scientific method, which I happen to love the scientific method. It's an amazing way to discover, to create strong knowledge claims about the physical reality. It's great.
Yeah.
It's not always very fun, right? Like, do you want to do an experiment or do you want to do some cool thing? Like, that makes kids say, wow, that's really neat. What's that all about? Which I always just did like, really an engineering fair kind of project or something. Kind of sounds like what you're doing. You're like, science, whatever. Okay, I'll contrive an experiment. I want to code a neural network. So here we go.
That's exactly right. Yeah. I don't remember anything about the scientific method in that science fair. If I'm going to be honest, I kind of ignored it. But you're right. It is the like finding your passion and your love, right? That's what it comes down to, I think.
Mm-hmm.
So I think that moment was like, what are we going to do? Because we had worked for, I don't know. We actually started immediately after the last fair. We had worked at like most of a year trying to put this together. And we had a demo that worked. And it was really cool. You could like, it would ask some questions, you would answer some questions, and then it would allow you to ask some questions based upon that knowledge. And of course, we had a happy path demonstration for the judges that we could do. But it all fell apart. And so the question was, but like we couldn't just pull out. Predominantly, also one of the reasons, like I kind of wanted to give up, but like my aunt had made this super fancy science fair backdrop for me. So it was like hand painted and it was incredible. It was like much better than I deserved. And I feel guilty about this ever since, but like, it's like, well, I can't pull out. She did all that work. Like I got to do something. So the challenge was, okay, well, how can we demonstrate it to them? Or how can we put it in terms where they can understand what we're trying to do here with natural language? I don't even think I called it natural language then, to be honest. Mm-hmm. But like this graph. So we tried to build a demo. We couldn't get it like a fake one. We were going to say, we did the real work, but here's a fake demo.
Right.
Ultimately, it failed. Like we just did not have something we could demonstrate at the science fair. And so when the judges came around, what I tried to do was explain all the work we had done for that year in terms they would understand. And the punchline was, we failed at that too. Like, they just didn't get it. And so like that probably was the single most difficult moment of my technical career. But I would say what I learned from that, and what we did was so much more ambitious than the year before, to be honest. Mm-hmm. And what I learned from that was like trying to, like how valuable it is to be able to express some technical approach in terms that your audience really can relate to and then they can see. Because, I felt like if the same thing had happened, and I did not do that with that second science fair. Like I should have done that. What I should have done was thought about what this meant in something that everyone can relate to, instead of trying to go into, we baked this, we had these nodes and we have these edges that link them and we could traverse the graph. Instead, I should have done some terms that they understood. So I've seen this play out a few times in my career, but that was the worst moment. It was like, what are we going to do? But it was maybe formative in why I got to where I am, I guess.
I totally see that. Now, a quick word from our sponsor. Confluent Developer, the podcast, is brought to you by Confluent Developer, the website, which has everything you need as a developer of data streaming systems. And it's completely free. We've got curriculum, hands-on exercises, executable tutorials, the online data streaming engineer certification, also free, a way to find a meetup near you. Those are free. Everything is there. I really want you to be successful in your journey as a data streaming engineer, and this is the site that has what you need. Check it out at developer.confluent.io. That's developer.confluent.io. Now back to the show. Because so a lot of the times when I ask folks this question, I'm like trying to dig into what was wrong with the world before you went down this path. Well, in your case, you were curious, and the first year you're like, what would be awesome is if we wrote a neural network in C.
Yeah.
Now, so most people, and I don't think any of them are listening to this podcast unless it's in the car and somebody.
I'm sure they are, Tim. Whoever, I don't know who people you're talking about, but I'm sure they're listening.
Well, most people don't think, what I was going to say is, don't think that sounds awesome. Okay. That's not typical. That's the thing you and I have to recognize that, because I'm with you. I'm like, that is pretty freaking awesome. Teenage Will, like neural network, next year, knowledge graph, natural language processing. I'm on this because it's cool, right?
Yeah, not back then. It wasn't.
That was just before the internet. Yeah. So you and I, just a couple years older, and that was definitely, no, it was not cool to be into computers in the 80s and early 90s. That, 10 years later, a different game. But you were curious. You were amazed by the fact that those are things you happened upon a book describing technologies that in a much more developed and compound form, changing the world right now. Through the transformer architecture and large language models. Yeah, changing it or turning it upside down or some version of that. But you just thought that was awesome. That there was no problem. There wasn't anything that pushed you on a journey away from home other than, that's dope, I'll do that. And I just want to highlight that because that kind of curiosity isn't usually, like when you're talking to a customer, I'm going to guess that's not usually what starts a customer on some initiative, but it is what starts people discovering things. So that's a different kind of beginning. I'll let you respond.
Yeah, it's true. I mean, in hindsight, like that sort of approach is like kind of what I would never recommend a customer do.
Ever.
Right? Because I was like, oh, I had something I wanted to do looking for a problem rather than the inverse is like, oh, I know I have a business problem or a challenge. I need to solve it.
Right.
But I guess that is kind of the point of like academia to some degree, or R&D is like, you don't necessarily has to start with a problem. You can start with the creative exploration side, I guess. So.
You can start with, what would be cool. And the contrast is important because you're right. When you're talking to a customer, hopefully that customer is not starting with, it would be cool, right? They need an outcome. They need to make money, save money, mitigate risk. They need to know what the numbers are and what these objectively observable things that they're trying to accomplish are in a business because they're responsible, they're agents, and they're responsible for managing the resources of the principal, of the owner, of whoever, shareholders, whoever that is.
Yeah.
All kinds of, that's what they do. And so now, talking to customers, there's this like vicious utilitarianism that you have to truly, for valid reasons, you have to respect. But I mean, behind me, if you're looking at the video version, wrong way, there's some shelves back here and you can't see, there's some electronic test equipment and stuff. Yeah. I like to make stuff because it's fun. Like, are there easier ways to solve all those? Yes, but it's just kind of cool, and that's a separate thing from the quasi-selling that you do. But I love that about young Will. That's all I wanted to say. That he was good. He wanted to do something.
Yeah, it was.
And
it was good
you already
times.
said this, but he learned a lesson. Talk about how. Maybe give us an example of how you see that play out these days when you should have been able to describe this deeply technical thing that nerd you cared about and these teachers had no idea what you're talking about. You should have been able to make it relatable. Yeah.
Yeah, I think for me, the way it plays out now, and by the way, I don't always do this. Like, sometimes I get wrapped up in myself or some technology or whatever. But, in general, what what it's taught me is like the first thing that matters is the first thing to realize is like the person you're talking to is who matters, right? So
Mhm.
understanding them, understanding where they're coming from, and then relating ideas with a narrative that they care about, like tell a
Mhm.
story,
Mhm.
storytelling. Because I'm sure people have
Where
said this. I'm
the
sure you've said this. Like we've been telling stories for I don't know since
since we've had words.
100,000 years or something like that.
Yeah, since we've had words.
Since we've had words. And and I think so. So a couple things I try to do is like it is intensive because I talk to literally hundreds of customers in a year, or certainly triple digits. Um, and so you don't, prepping for each one and trying to understand where they're coming from, what their, what their business does. Like, even though I work across a lot of industries, I'm telling you, it's hard. It's like, there's only so much you can fit in your brain, right?
So I don't. I mean, you do customer meetings for your job.
Yeah.
In my work responsibilities, I do them sometimes, and I love them because it's this constant struggle to understand. Like maybe you have an hour, and you are just kind of flying through the conversation. Number one, trying to understand their business.
Mm.
Can I wrap my mind around what it is you do in enough detail to think about the technology stack and whether the stuff I've got in my bag here is any good to you? So I love that problem. Yeah, you're trying to understand the business. Sorry, go on. You're trying to explain it in
Yeah.
ways that they can understand.
So, I mean, that sounds like 101, but I think it's something to always be mindful. And I guess the second thing that I try and do whenever possible is I try to have a demonstration on hand that I can use to actually show some of these things. That's almost domain oriented. Say it's not always possible. You can't always have a demonstration of said, some technology, in this case, Confluent, ready that shows, how I am, optimizing supply chain for retailers,
Yes,
like
yes, or manufacturing process
or
for a
manufacturing.
pharmaceutical,
Yeah,
or
yeah,
blah, blah, whatever. It's not always domain specific, but it needs to be close for this executive
yeah.
type person.
Exactly. That's right.
Yeah.
Because you otherwise they'll fixate on the wrong things. So that's the other thing is like I try because I remember like doing like explaining my science experience, experiment using like Aldous lamp or what's the flags they use?
Yeah,
Semaphore.
semaphores. Yeah,
Yeah, yes.
right.
That's not fun. It's much better to show it. It's much better to show that AI pitcher pitching baseballs.
Yes.
So yeah, I think those are the things that I kind of like. I failed miserably, and I learned allowing people to see things in action is really really powerful, specifically if it relates to them and understanding their perspective and where they're coming from.
Hmm.
You know, technical problems are I love it. Like they're when I knew what I was preparing, it's like there were so many projects I worked on that I really really loved that I could talk about and geek out on. But like honestly, if you have enough time and, you're willing to put some sweat into it, like you can do some amazing things, I think. So like the technical challenges I never found to be the hard ones. It's always the human ones that I thought
Yes.
were the hard ones for me anyways. So
And I think this is a key. This is just kind of coming to me now. So you're helping me realize some things. I love this conversation. The reason why we have technological advancements of any kind, I mean, you and I care mostly about software. There's all kinds of other technology. There's metallurgy, there's chemistry, whatever. Pick the thing you like. The reason why we have those things is because somebody at some point said, "Huh, it would be cool," or "Oh, that's weird," and they wanted to dig into it. They wanted to do something. They wanted to understand it, and they were very focused on the thing. And that's not a people problem. They're focused on the thing, and that's you picking your supposed science fair project, really an engineering fair, because that was more awesome. It's what you wanted to do.
yeah,
You're not thinking about people. You're thinking about the thing. And that sounds like a negative framing. It's great because you have to think about the thing. There has to be somebody who wants to do that. Otherwise, there's no technological innovation. When it comes time to explain that thing to somebody, like if you happen to be selling it and you're interested in helping somebody make the decision to buy it, well, now that's a people thing, and you have to explain it in terms of them. You have to understand them and tell a story that's relevant to them, which is not the same as, let me tell you how awesome this thing is.
Yeah.
For you and me and anybody else in this business, you can stop there. It's awesome. You just want to think about the thing.
Yeah.
But you have to be, and this is something I think magical about the pre-sales / field CTO kind of world. To some extent, DevRel, what I do is a little like this, but I think it's a bigger deal for you. You got to be able to know the thing, which means you're intrinsically interested in just geeking out on the thing, but then you got to be able to pivot to people. You got to be able to do both at the same time. It's kind of a little magic there.
Yeah, it is. I love it. I'm not going to lie. Like, people ask me, what is it that a field CTO does? And I describe it. And like, I'm not going to lie. I have a great gig. Like, it is a lot of fun. I mean, I imagine same thing goes for you. As much as I love my job, like, there's some things, that maybe I'm doing X, Y, Z. I'd rather be doing something else. But on whole, it's an amazing job. Like, I feel very blessed.
As they say, the lion does not concern himself with Slack notifications and but yes, it's amazing work that we get to do.
Yeah. And it's the other thing I think it's great about it. And I always say this to people, like, when you're thinking about where in an organization like this you're working, the other really great thing, it doesn't have to be field CTO, but like, when you're working across a lot of customers, you just learn a lot of interesting things about businesses and meet a lot of really cool people. I mean, that's a lot of fun too.
Exactly. Boy, yes.
Whereas, like, so that's, for me, there was always the tension. I love building things and I love seeing it come to fruition. I just love that. Like, oh man, I feel so good when I open up an IDE and start coding. But when you do that, when you're focused on from cradle to, I'm not going to say grave, but cradle to delivery.
Yes.
It takes a long time, and so it's hard to get sort of the breadth. So it's like a sacrifice, I think, for me anyways, because I love both aspects. I'm sort of sacrificing the engineering side, which I love so much. But it means I get to talk to a lot more people and hear a lot of interesting problems and stuff like that. So that's sort of the balance. And I think people just need to think about that. Like, what do they love more? Right? Because it's important to love your job. But anyways, I'm rambling.
Good distinction, and I think good challenge. What thing do you love more? What balance do you want between thing and people? And that helps you position yourself in the whole spectrum of tech careers.
Yeah, definitely. Yep.
My guest today has been Will LaForest. Will, thanks for being a part of the Confluent Developer podcast.
My pleasure. Thanks for having me, Tim.